to get cut off on that number 8. So proper notation again, T for capital, or capital T for transformation. And then I moved 6 units to the left and 7 units up. And then I need to specify what figure I'm translating here. It's triangle RSV. To get me triangle R prime, S prime, V prime. And that's it for that one. All right. So moving on to number 9. So this time I'm going to translate quadrilateral Rstu along the vector -3, -3. So let's go ahead and let's first graph Rstu. So R would be at 2, 5. S is at 0, 2. T is at 1, -1. And U is at 3, 1. So this is what my quadrilateral looks like. And to translate it along the vector -3, -3, what that means is I'm going to move it 3 to the left and 3 down. So R moving 3 to the left and 3 down. That puts me right here for R prime. S moving 3 to the left and 3 down. Puts me right here. T, 3 to the left and 3 down. Puts me here. And U moving 3 to the left and 3 down, puts me here. So this is what my new figure looks like. These figures are congruent because they're isometric. No size change occurred. So now it says to write the translation and mapping in proper notation. So for mapping, again, you can use any capital letter, does not matter. I'm going to use, let's use H. Does not matter. So transformation H, I'm taking every X and Y value, and I'm subtracting 3 from the X values and subtracting 3 from the Y values. Now for proper notation, the capital letter you choose does matter. Or since it's a translation, we're going to use T for translation. My vector is -3, -3. And then I translated quadrilateral Rstu to get quadrilateral R prime, S prime, T prime, and U prime. I didn't address this, but when we're doing triangles, we should always put the triangle in front of it. And if we're doing quadrilaterals, we don't need to put anything until we get to our quadrilateral unit. Then I'll show you how to name quadrilaterals. All right, so number 10, it says, in the problem below, draw a sketch of the given transformation. So we are going to transform line M along vector CD. So what that means is that I'm going to take this line and I'm going to move it the same distance as ray CD and in the same direction, which is up and slightly to the right. So moving line M up and slightly to the right would look something more like this. Whoops, let me draw a more straight line. Something like that. And that's it. That's all you want to do there. And then we've made it to our final question in the translations lesson. It says, using the given figure, state a translation using proper notation that would create the given vocabulary term. And it says to add and label the vectors as needed. So I'm just going to randomly assign these points letters. So I'm going to use G, M, and H. And what we're trying to define is the term midpoint. And we're given that G, M, and MH are congruent. So we are trying to define that, that M is the midpoint using a translation and proper notation. So basically, to prove this, or to show that M is a midpoint, even though we know that it is because GM is congruent to MH, what they want you to do is they want you to state that we're translating segment GM along vector GM and it will lie on top of segment MH, which proves that GM would be congruent to MH and M would be the midpoint. Basically what this is saying is that if I'm looking at vector GM, which is this vector here, and I move point G, the same exact distance as that vector and in the same direction as that vector, G would then lie right on top of M. And if I move M the same exact distance and direction as the vector GM, M would move right on top of H. So the pink segment is the new segment that we would have, and that shows that GM would be equal, because it would lie on top of segment MH. And that is it. You are now going to move on to your reflections lesson.